Thank you, everyone, and welcome to the Intelligent and Secure Edge panel. We have a wonderful experts panel here today, and we're looking forward to an amazing discussion. My name is Rajan. I am the Chief of Staff and Head of Marketing and Communications with the Samsung Strategy Innovation Center at Samsung Electronics. So without further ado, let's meet the panelists. Why don't we start with you, Ravi? Take us away.
Hi, I'm Ravi Subramanian, Senior Vice President for all IT verification at Siemens EDA. Background is primarily half in the semiconductor industry and half in the design technology, design automation industry.
Thank you, Ravi. Amit, why don't you introduce yourself?
Sure. Thanks, Rajeev. I'm Amit Gattani. I'm with Micron, currently Senior Director of Corporate Strategy and Innovation. I recently moved to corporate strategy in this role from embedded business unit, where I spent the past 7 years. So I've got a lot of experience in the embedded industrial IoT and automotive space.
Thank you, Amit. Dirk, why don't we have you introduce yourself?
Yes, hi everybody. My name is Dirk Slama. I'm a vice president at the corporate CDO office at Bosch. Most of you will know the company. We're a global engineering and manufacturing company, and this topic today is close to our hearts.
Thank you, Dirk. And last but not least, let's hear from Dennis.
Hi, my name is Dennis Ciplickas. I'm Vice President of Advanced Solutions at PDF Solutions. I've spent years in the manufacturing side of things, working on yield ramps and characterization and test structure and IP development. Most recently, I'm working on solutions that connect data across the supply chain from design all the way through manufacturing to in-life solutions. So this idea of cloud and edge and how does that all connect and get smart is fascinating to me, and I'm looking forward to the discussion today.
Thank you much, Dennis. That's our panel, and so let's get started. This is a very big topic area, so I thought the way we could have an engaging discussion is let's start with the big picture of what the edge and intelligence is all about, and then let's narrow down specific areas, and then we can get into some of the issues. So Ravi, why don't we start with you? Give us the big picture of the edge and what it's all about, and then try to zoom into what is intelligence and security on the edge, and why is it so critical for our infrastructure?
Great, thanks, Rajeev. So the edge refers to the end of a managed network. It could be a telecom central office, a cell site base station, a factory floor, or a vehicle, or even an oil rig. The edge is really the growing focal point right now for the next generation of compute platforms, hyperscale service providers, connectivity service providers, and even the whole IT industry. It's all about bringing intelligence that is both compute and storage closer and closer to the data source. And the edge is just rapidly growing at a breakneck speed. The industrial and automotive markets are leading the way there. And I truly believe there's a revolution going on at the edge because of rapid changes in sensor cost, data storage cost, device ubiquity, and connectivity. This revolution is happening on 5 dimensions, and those dimensions really define intelligence and security. The first one is data creation, then data storage, data transmission, data analytics, and data security. At the end, data is the heart of driving this revolution. And when we look at how that revolution is playing out, it's playing out from the standpoint of computing, where edge computing is rapidly evolving. Automotive processors have moved from 16 to 32-bit to 64-bit, and along the way moved down to 7-nanometer technology. Factory automation processors now used in industrial PCs are multi-core SoCs. Software stacks are growing. Essentially, in computing now, we're seeing the birth of microdata servers and even servers on wheels when it comes to talking about autonomous vehicles. On the networking side, the needs of the edge are driving key innovations in standards, time-sensitive networks, as well as automotive Ethernet. On the communication side, connectivity with 5G and network slicing is enabling customizing the network performance down to the device level. On storage, we're seeing that the edge is driving the accelerated adoption of SSD and NVMe primarily due to the unique requirements in those environments. And finally, last but not least, security. Security at the edge is a multi-dimensional challenge. The threat surface at the edge is significantly increased because you're now in a remote environment, often unmonitored, and there is a need to ensure hardening of every host, the real-time network monitoring, the need for protecting the data, authenticating any users, and having specific security measures to access and control access. Things like TPM, privileged access methods, and secure provisioning are critical. When we look at the automotive and industrial segments, they're really leading the way in this revolution at the edge. Security at the edge for automotive is critical. There are rapid increases in electronic content, and platforms today are being defined by compute and software. People talk about safety in automotive, but there cannot be safety without security. And ultimately, as a software-defined platform, these edge devices, such as cars, ultimately have a business value that's already being demonstrated through software-defined platforms by companies like Tesla and others. Ultimately, the ability to ensure security on the platform at the edge is first and foremost to be able to deliver the promise of intelligence at the edge.
Thank you, Ravi. So, as I think we heard from Ravi, it's a big place, the edge, and there are different elements and quite a few moving parts. So a couple of things that stood out for me in what Ravi said was, it's a multifocal platform, as well as it's a multi-dimensional arena where security issues can happen. So now let's go to you, Dirk. At Bosch, you see the entire array of elements from sensors all the way to different parts of the edge architectures, obviously including automotive, as Ravi mentioned. So what are some of the common security issues that need to be addressed? And what's the role that standardization can play in this?
Thanks, Rajeev. So I think this topic really goes across all of the industries that you mentioned. So at our company, we see this obviously from industrialization, Industry 4.0, it's a big topic, automotive, building and construction, smart home, logistics, energy, and so on. And I think when you look at it, you really have to look at the holistic picture. So a lot of intelligence, yes, is being moved to the edge for very good reasons, technical reasons, strategic reasons, and so on. In most of the cases, we have to look at this from the perspective of a distributed system architecture. So there are topics like latency and bandwidth that we have to deal with, and where edge provides us with a benefit across all of these different areas that I was just talking about. Another thing is that when we are talking about edge intelligence, is that I think there's, well, at least two different types of intelligence that we're dealing with in these types of distributed systems. So at the edge, what we see very often is what I would call product intelligence. So this is a kind of intelligence that's typically more engineered, either by deploying very sophisticated algorithms or by actually utilizing AI, ML type of mechanisms, and then using manual labeling or very advanced simulation environments. So this type of intelligence is what I would call an intelligence that we really have to get right the very first time, right? Whereas when we look at intelligence in the cloud, very often this is more, I guess, what you could call swarm intelligence. So this is intelligence that builds up over time in the live system, where you continually improve the system. I'm not saying that the edge intelligence is not improved over time, but for this type of swarm intelligence, that's typically something that's not utilized at the very early start of the product or system lifecycle. So I mean, if we look at the systems that we are talking about, those typically combine physical products edge intelligence, cloud, and so on. Yeah, and because of the product component, there's going to be a typical, start of production, and the edge, the first incarnation of it, has to be 100% safe and secure at the start of production, because obviously anything that's related to hardware can't be updated at a later point in time or only in the next product generation. Yeah? Anything that we're doing in terms of software or AI updates in the edge undergoes a more complex process in terms of releasing because of the safety and security requirements than anything that you would typically in the cloud. Yeah? So this is what basically makes edge intelligence so specific. Now, the requirements, of course, differ from industry to industry and from use case to use case. So, Ravi, you were mentioning, for example, TPM earlier on. Yeah, I mean, that's obviously something that's of high relevance when we're talking about a critical system. Yeah, when there's danger of any kind of hardware tampering that would cause harm on a physical level. Yeah. Whereas if we're talking about a low risk type of component, then it might be overkill. Yeah. So it's really very use case specific.
Thank you, Dirk. So again, many moving parts, and one of the areas that I really liked that Dirk went into was the criticality of the production cycle. At start of production, it's really important that care is taken, because once the hardware devices are out in the field, it's very difficult to make changes to them. So now let's go a little bit even deeper than that. Let's go into the verticals area. And so in today's world, manufacturing supply chain, whether it's semiconductors or end products, is economically extremely valuable and critical for the entire world. So Dennis, why don't you take us to the assembly line and the semiconductor fabs and highlight the challenges and the opportunities you see for intelligent and secure manufacturing?
Yeah, thanks, Rajeev. Happy to do that. The architectural concept of the cloud plus the edge is having a profound impact on semiconductor manufacturing. For years, the various players in the supply chain have approached analytics with an on-premises approach similar to that of the big iron manufacturing line itself. Everything kind of happened inside the building, inside the fab, or inside the organization, tightly controlled within that physical environment. This wasn't only just natural since it was a factory environment, but also efficient and secure. But what we're seeing is that the need for more and more data is driving a change in the databases, which is then a change in the architectures of the analytics systems, which then drives it to the cloud, which offers really good options for that. So the historical thinking no longer really applies if you need to process, for example, the hundreds of thousands of wafer sort measurements per chip. It used to be thousands. Now it's literally hundreds of thousands per chip. Or if you're looking at the wafer making tools, there's millions of sensors of data points collected per wafer. So in order to actually assimilate, process, and gain insight from this data to put intelligence at the edge, you need to move to this cloud architecture. We saw this growing a few years ago, and in the last couple of years, we've really seen our cloud analytics business taking off in ways we never really expected, say, 10 years ago. The cool knock-on benefit of this is that putting this data together in the cloud gives you the large data sets really needed for machine learning, which then creates this possibility for these intelligent or AI-enabled flows at the edge, in the fab, on the assembly floors, and on the test floors. One example is the manufacturing tool sensor data that I mentioned. As each die or wafer or module is processed, there's a bunch of sensors on a tool, like your car has, sensors for braking and yaw and those types of things. These tools have all of their own sensors as well, generating data at kilohertz rates. These waveforms give insight into, is the tool behaving well? Or is the tool behaving differently than before? Or is it behaving badly in some known bad operation? So this data needs to be collected on the fly from the tool And machine learning is well suited to go mine this data to go figure out what's anomaly, what's not an anomaly. Then these models can be pushed back to the tools. I think mentioned earlier, there's in the industrial IoT, there's now computes with multi-core SoC living right there at the edge. This is exactly the use case for that, in order to evaluate on the fly during wafer operation, is this thing what I expected or not? It's worth mentioning that the same concept here of sensor data collection at high speed and then evaluating it against trained models for anomalous operation applies exactly to sensors inside of chips. In the past, these types of sensors were used for things like power or thermal modulation of the chip, to meet a certain mission profile. But now there's more and more sensors in there looking for anomalous operation, even, for example, for security issues. Is this chip operating in the way that I expected, that I validated at the beginning? So moving from sensors to test, another example, and this speaks toward the swarm intelligence, Dirk, I think you brought up. You made a lot of sense when you said at the very beginning, things need to be safe and secure at the launch. Same thing applies to wafer and chip testing. So there's always a trade-off between quality and cost. And typically there's a certain set of tests that are developed during new product introduction that are kind of locked in and used to launch a product. But over time, adaptations are made, either due to quality and the need to improve quality in certain areas, or because of cost as average selling prices go down over the lifetime of a product. So knowing that you're going to be making modulations to the test flow, and it's not a fixed thing, the leading edge adopters of this intelligent edge are building this ability to adapt into their test flows, such that as more data is collected over time, and this is, if you think about multiple products over time, they create this swarm of data that can then be pushed through the learning models and then driven back into the test flows, so that for any given test budget, it starts out this much and then goes down to this much over time. You're making the most effective use of that. The move to the cloud and the need to move all this data around is driving security measures, obviously, not just the typical ones like encrypting data during transport, encrypting data at rest, but what we're seeing is actually even encrypting data within the tools themselves before it even leaves the tool, in order to create private data streams so that the tool OEMs can monitor their tools and improve their operations. Standards are evolving for this. Things like EDA Freeze 3, which is a data collection standard, not EDA. Sorry, Ravi, it's not electronic design automation. It's I think it's electronic data acquisition or equipment data acquisition, something like that. So there's standards evolving to support this secure data generation on the fly, and we're being pushed in our areas to enable as close to zero trust as you can get. It's not really super practical to achieve the goals you have with zero trust in terms of intelligence, but things like encrypting models and only evaluating in memory and then deallocating is something that we're being pushed to. So I think to really achieve the full benefits of the intelligence at the edge, we're going to have these security measures built into not just the data movement, but also in all the individual operations on that data as it's moving through the system. So, yeah, super interesting topic. Thanks for the chance to talk about it.
Of course, no, it's super broad, and one of the elements that you touched on towards the end, Dennis, was about trust, right? So we went from end markets all the way to the assembly line. So we're looking at this now from a solutions perspective. So I'd like to go to Amit now. And Amit, as part of your job at Micron, you look at cybersecurity from a corporate strategy lens, look from an end-to-end perspective, right? So why is trust so important in the edge and the cloud scenarios? And how can it be managed? That's my first question. And the second is, what is the role of semiconductor companies and opportunities in this space?
Thanks, Rajeev. It's a very interesting topic and very close to my heart, so to say. It's like all the speakers have said, this is a big conversation in the industry. Edge is evolving pretty rapidly, and we need to address all of these issues. So, to start with, right, like Ravi and Dirk have indicated, there is a lot happening on the end devices, whether it's the intelligent end devices, edge gateways, edge servers, because that's where the data generation is. That's where kind of the data processing needs to be and storage needs to be. Now, the concept of having processing near the data is not necessarily new, right? In a disconnected world, all of these devices were islands. The difference now is that we don't want these to be just disconnected islands. We want them to be centrally managed and share their wisdom or whatever they learn on the edge back with the cloud services, so that you can build this swarm intelligence that that can benefit the whole fleet of devices, right? And we want to do this with tens of billions of devices. So there's this expectation of autonomy in the field where the devices can act and make their decisions, but you still want them to be connected to the centralized services for management and sharing of that intelligence back. As an example, if an autonomous vehicle or the drone runs into a new corner case, you want it to make that real-time decision of new path finding or safety or whatever it may be, but you also want it to share that newfound wisdom back with the cloud service so that rest of the fleet can be updated and new solutions can be deployed. So given the scale of this thing, we want all of this to be done by the machines, and that's where trust becomes foundational. We have to ensure that we can trust the remote device, trust the connectivity, trust the data that it is sharing, and trust the decision it's going to make. More distributed the use case, the more we need to establish trust at the edge of where the data and decisions are. And hopefully what this example illustrates is that this is truly an end-to-end problem. You can't just solve it on the device or the cloud. The reality is that this is an end-to-end problem that needs to be addressed in a more comprehensive manner. So to your point about semiconductor companies, semiconductor companies play a very critical role because we are at the heart of all of these devices, whether end devices, edge gateways, servers, or whatever they may be. But it's not just about enabling hardware-based identities in these end devices. It's about working with the ecosystem on how these capabilities can be traversed back to and be used by the cloud service providers. And that's how you have to look at the problem in a holistic end-to-end manner. Now if you think about it, in the past, these parties haven't really worked together, right? When did semiconductor companies work very closely with IoT or cloud-based service providers? This is not something that has happened before. But this is truly where we need to go, right? In the past, a lot of our customers have said, well, yeah, we have this security capability that's enabled by a semiconductor SoC or something, but we don't use it because people don't know how it is going to be tied at the next level and the next level and at the whole ecosystem level, right? So there's an opportunity for the companies to get engaged in thinking end-to-end problem and solutions. And there's a tremendous opportunities for industry bodies like GSA to facilitate this ecosystem, right? As an example, at Micron, you mentioned that I have been driving a cybersecurity thinking and the overall solution development for some time. And we have our Authenta Secure Flash for hardware-based identities and many other secure capabilities. But we have taken an industry leadership and established a live key management system that acts as a trust authority for in-field use cases. Now, we haven't just done that. We are bringing a lot of cloud IoT service partners to the platform so that we can take to our customers an end-to-end view of the problem, the solution, and give them a turnkey approach to how they can deploy the services on the semiconductor and the device side, and how this would work with the cloud services guys. So we think that is necessary. Things like these are necessary to accelerate intelligent edge and achieve the promise it holds. Like Dirk mentioned, security has huge ramifications, and you want to do it right from the beginning. Otherwise, it slows down the whole service economy, which is kind of the bigger part of any of these economies, right? It slows down that economy. So you want to do it right, and you want to expect more from everybody in that, and you want that collaboration in the ecosystem. So I would really challenge, Dennis and Dirk's view that, hardware is fixed. No, hardware shouldn't be fixed. Even hardware should have that capability for in-field updates and ability to deliver new policies and things like that. And that's how we have to think. We need to leave behind the concept that hardware is just fixed and you can't change it. Yes, it's true in some extent, but there are capabilities that we can update in the field.
Thank you, Amit. So, as the discussion evolved, it started with edge. Obviously, security was the underlying layer. Then we talked about swarm intelligence, and we talked about cloud. And then where AI, ML, and where there's AI and ML, there's data, right? So this is a little bit of a tangential question, but when you have data, you have privacy and security. So I'd like the panel to, give their inputs on what is the significance of AI ethics in security and privacy in our industry, and how do you view it? Dirk, could I start with you on that?
For us, this really is paramount. So we really believe that successful AI has to be trusted AI. And I mean this both from a B2C as well as from a B2B type of perspective. So we've actually, for the last 2 years, helped starting a group that we're calling the Digital Trust Forum, or DTF. And in the DTF, we are bringing together hardware companies, software companies, companies related to the traditional testing and inspection type of arena, like their TIFF, for example. And we're bringing together industrial players. And actually, the persona that we're assuming as a key persona in here is what we're calling the digital OEM, right? So the traditional OEM that's now adding value-added services, digital services to its traditional physical products. And as these products become more intelligent, we really do think that trustworthy AI is going to be one of the key success criteria. So we are currently working on an initiative actually to establish an AI trust label that's looking at key aspects like transparency related to data, but also to the AI algorithms. That's looking at accountability, both from a technology as well as from an organizational point of view. Privacy, naturally, you mentioned that. Justice in terms of bias, fairness, the social perspective, reliability is a big thing. I mean, given that in AI you don't have an algorithm that you can debug, so the whole topic of explainability becomes a huge topic, and last but not least, sustainability. So this trust label that we're currently working on, it's still early stages. We hope to have a first version of this available this summer. If this is something that anybody in the audience is interested in, please do reach out to me. We would be very interested in also getting your perspective. I hope that underpins how serious we are taking this.
Okay, Ravi, you had a comment here. Sorry, go ahead, Ravi.
Sorry. I'm delighted that Dirk brought up the Digital Trust Forum. Ultimately, in going back to your question, it is really about what do we mean when we say the word trust? And I just want to share a very useful definition that I have heard and in practice to answer questions like were posed. And that is, trust is having the confidence in the integrity of an element in a system. And so understanding the definition of the integrity is really about, does it do what it say it's going to do in terms of its function, how it protects data, who it gives access to, etc. So using the definition of trust, being confident in the integrity of an element in the system, I think ties in well with what Dirk said, but ultimately really comes back to the question of AI and ethics. Are the AI algorithms that are running actually doing what they say they're doing? Are we using the data the way it's intended to use? And are we making decisions on that in a way that's intended and transparent? Thank you.
All right. Well, thank you, Ravi. And, that's really an interesting topic here. Does anybody else on the panel have any other points related to AI and ethics?
I can chime in here just a bit. I mean, I really like Ravi's definition of trust, and I think we have an opportunity in the industry to change the narrative. Right, for decades, security has been considered a cost adder, and it's been used as a insurance against bad things happening. Versus, can we think about trust as an enabler of various services and the economy that you want to create? I think we have to rethink how security is positioned, because when you just put it as an insurance need, you're always doing a risk assessment. Versus when you think of trust as an enabler to all the things that you want to do with the edge and the IoT, then it just becomes a very different dialogue. I think that we all owe that to do that in every conversation and every narrative that we drive in the industry, because it is extremely important, as many of the panelists have said, that we get it done right. Otherwise, it just slows down the momentum. We have to get this thing done right from the beginning. Otherwise, you're gonna have a very slow rollout and slow take rate in this. So.
I see the timer ticking, so we are coming up to the end of our panel session. So once again, thank you so much to all the panelists. It was an amazing discussion, very insightful. A pleasure to have been here along with the panelists. And we also thank the GSA for giving us this opportunity. So with that, we'll close the panel. Thank you all.
Thank you.
Thanks a lot.
Thank you.